the third talk will be called VisLitE. VisLitE, Visualization, Literacy and Evaluation, and will be presented by Bob Laramee, who is here, and it's co-authors with Elif, Firat and Alark, Joshi, and we are very happy that you accepted the invitation to present at the Eurovis, and we are looking forward to your talk. Again, afterwards we'll have a Q&A session, so if you have any questions, think about them during the talk, and then we'll be able to post them afterwards. So, welcome, and looking forward to your presentation.
Thank you. Thank you to the Editor-in-Chief of CG&A for inviting the papers, and the Eurovis conference organizers for inviting the CG&A papers. We were very surprised, actually, when they invited us, so that was a nice surprise. We actually tried to present this at Viz last year because the Viz conference also has invited CG&A papers, but they said, no, you're too late. Like, we've already used up all our slots. So yeah, this is a collaboration between Elif, Firat, Alark, Joshi, and myself. Elif was a PhD candidate at Nottingham University. She has since graduated. This is really her work, and I'm going to try to present it on her behalf. Just for fun, this is actually inspired by Robert Kosara. I watched Robert Kosara give a nice history of a paper he had published. So I'm going to give a little history of this paper. It was originally submitted as a survey paper to IEEE CG&A. It was rejected. And somebody behind the scenes, I think it was Pak Wong, I'm not 100% sure, saw it and thought, oh, that would, a version of that would make a nice contribution to the education department. So actually, Beatrice invited us to submit a kind of tutorial-style version to the education department. So that's how this one sort of evolved. So we decided, okay, let's turn this into a tutorial-style paper and submit it to the education department. So that's where this appeared. So actually, there are two invitations. One was the tutorial paper, and then one was to present it at the conference. And because CG&A has this special restriction on the number of citations, what we do to get around that is we cite this survey, the so-called original survey. So the original survey on visualization literacy is in the Information Visualization Journal. So we're often citing this inside the tutorial to help us out with the citations. Also, one thing I did want to mention, if anybody has questions or comments during the presentation, I'm happy to answer them or discuss things during the presentation, actually. You don't have to wait until the end. And in fact, if nobody says anything, I'm going to actually start calling on the audience. So don't fall asleep. Okay, so what is the inspiration behind this? The inspiration, well, this was a book I just listened to, The Psychology of Money. I was surprised to see this quote in there. It's difficult to learn from something you can't see. Good for the visualization audience. The topic of visualization literacy is growing in momentum and importance as a general topic. And that's because as a society we're becoming more and more data-centric and more reliant on data to make decisions. Right? Data in its visual representation is used more and more to support understanding and decision-making. So in conjunction with that is visualization literacy, our ability to interpret the visual representation of data, right, and make informed decisions. Visualization literacy is critical for this, right? Here's a little chart that illustrates the visualization literacy literature, say that 10 times fast. And it shows on the x-axis the year of publication, and then on the y-axis the number of publications on visualization literacy. So this goes back 20 years, and we can see from 2000 to 2010 or 2012, visualization literacy did not attract much attention. But since 2014, the amount of attention given to this topic is increased. And I'll give a little plug to tomorrow's best paper session. We have a visualization literacy paper in the best paper session tomorrow. Surprise, surprise. Hopefully you cited this.
I don't remember.
Okay. So what is visualization? Well, visualization literacy, this VisLitE paper makes some contributions. It's the first kind of introduction on the topic of this kind, with a special focus on evaluation. So one of the things we learn in the visualization literacy literature is evaluation is difficult. I mean, that's true about all visualization papers. The evaluation section or component to the work is often very, very difficult, and that's very true of the visualization literacy literature. So we offer a unique and novel classification of the research papers in this area, and it's based on, surprise, surprise, the type of evaluation that is conducted in the literature. So we have 4 different styles of evaluation, which we're going to discuss. So-called in the wild, controlled user studies, classroom-based settings, and then crowdsourced settings. And here we have a little illustration. So on the x-axis is the number of visual designs, or the number of evaluations, of a given visual design. So if I start at the top here, the bar chart is the most popular visual design to be evaluated. It's been evaluated in the wild. It's been evaluated in controlled user studies. It's been evaluated in classroom settings and in crowdsourced settings. So it's the most widely evaluated visual design in the visualization literacy literature. And then we have some of the other visual designs that are evaluated in the literature, like scatter plots, line charts, pie charts, and histograms. And they're listed in decreasing order of popularity and number of evaluations. So if you're looking for future work, this is a good thing to look at, right? Maybe you have a visual design that's not here, that hasn't been evaluated yet from a visualization literacy perspective. We also offer some beneficial meta-analysis comparisons between the literature to give an overview of the field and indicators of both mature themes and unsolved problems in this visualization literacy domain. So there is really no standard definitions as far as I know of visualization literacy. Here are some example definitions. But it's very much analogous to other kinds of literacy, like language literacy, right? We learn to speak, we learn to listen, read, and write, right? And we have other kinds of literacy, like computer literacy, mathematics literacy, and financial literacy. It's very much analogous to all other types of literacy. So we have here's a definition: a concept generally understood as the ability to confidently create and interpret visual representations of data, or the ability to make meaning from or interpret patterns, trends, and correlations in visual representations of data, and the ability and skill to read and interpret visually represented data and to extract information from data visualizations. even amongst the different definitions, there are two key elements or two key aspects. One is the ability to interpret, so look at a visual representation and then interpret it successfully and correctly. And then the next level is to create something yourself successfully and accurately and correctly, right? It's very much analogous to reading language and writing language. So reading visual representations and writing, or creating construction of visual representations. So we categorize the literature into the style of evaluation, because evaluation is very difficult, right? If you design a piece of visualization literacy software and you want to demonstrate that it's actually useful and effective, that is non-trivial. It's not easy to do that. So our four categories are in the real world, or it's also called in the wild. So this is a setting that you're not in a controlled laboratory, you're generally in a public setting. For example, a museum, and you invite people that happen to be visiting the museum to participate in some sort of an experiment, right? You can't anticipate who those people are going to be, from which age group they're going to be. You don't anticipate your test subjects, right? There could be random people. And you don't have a controlled laboratory environment in that setting either. The setting that I think we're all the most familiar with is the controlled user study setting, where you're in a laboratory, the hardware is fixed, the software is fixed, you know who the participants are ahead of time, and you give them a set of tasks, right? And you measure the time, the response time of each task, and the accuracy of each task, right? It's very fixed with very known variables, controlled known variables. There's also a classroom-style setting of evaluation, and this is typically in an educational department like a university, like right now, where we take a classroom of students and we divide it into two halves, the control half and the experimental half. And one half is given, say, the traditional form of education, or the traditional form of literacy, and then the other half is given some new experience with a new piece of software or a new style of visualization literacy test, right? That's novel. And then we run some sort of a comparison on how the two groups performed with respect to one another. That's the classroom setting. And then we have, of course, another familiar setting, which is the crowdsourced setting. This is when you conduct your visualization literacy experiment online. Right, and you open it up to a global audience. But you have very little control, or you have less control over this environment, right? You might not know which hardware they're trying to conduct the test on. You might not know geographically where they are. You might not know what time of day it is. You might not know if they're paying attention to the experiment and so on. So there are all sorts of unique challenges with the online setting as well. We try to compare these different styles of evaluation in a summary table from different dimensions, like the physical distance the participants are from the people conducting the experiment. So when you observe a participant in an experiment, how far away are you from that person, right? That's one of the variables in these different environments, right? In the wild, we could say that's a medium, an arbitrary word, but at least it's a distance that's visible. In a controlled user study, we're a very close distance to each participant, right? We might even be filming the user study while they're participating. In the classroom-based experiment, we're also very close to the participants physically. In the crowdsourced study, they could be any arbitrary distance, right? Anywhere on Earth. That's true of the observations, true as well. So we can make the closest observations in a controlled user study. This is one of the advantages of the controlled user study, is that we can make the closest observations. In the wild and classroom are comparable to one another, whereas in a crowdsourced study, it could be impossible to make observations about participants because we can't necessarily see them. And then one of the big variables is the control over the environment, right? Controlled user studies have high control over the environment. And then we have a little bit less control over the environment in the classroom-based, in the wild settings. Right? This is a trade-off that we make. And especially in the crowdsourcing studies, we have the least control over the environment amongst the categories. And then the number of participants varies in each setting. Right? Typically, controlled user studies have less, and then crowdsourced studies, the advantage is you can recruit hundreds or thousands of people to participate in your study very, very quickly. Right? That's one of the advantages of the crowdsourced evaluation. So here's just one example of an in-the-wild visualization literacy study. So from Borner et al. So they went to a museum and they interviewed museum visitors. And they showed them a set of visual designs. This matrix or this table is an example of what the museum visitors saw. And then based on what they saw, what they were shown, they were given a set of interview questions. And the interview questions were things like, how familiar are you with this, given this visual, this image? And could you name it? If you had to give it a name, what would you call it? And do you think it's useful? And if you do think it's useful, what do you think it's useful for, or when could it be used? So they did this with museum visitors, a group of museum visitors, that's so-called in the wild. And then they did an assessment of ranking. They ranked each image and each visual design by the level of difficulty and level of popularity and some other metrics. This is an example of a controlled visualization literacy user study. So Horan et al. Explored how users construct visual designs. So they were given a task, and they were given a set of tiles, and they were asked to represent a data set using those tiles in a controlled laboratory setting. So how would you visually represent the following data set using this set of colored tiles? And the goal of the user study is to deepen the understanding of the visual mapping process. In other words, how people think about this transformation from data to visual representation, what the challenges are, what the difficulties are, what are the parts that are well understood, and so on. With a special emphasis on what makes it easy or difficult. And then the goal is to come up with some guidelines about informing how to create visual information visualization authoring tools. This is an example of a classroom-based evaluation. So Firat et al. Designed a piece of software. This is a coordinated multiple views piece of software that links a traditional hierarchy with a tree map hierarchy. And the idea is the users can interact with the traditional hierarchy, which they already understand, and then see how those properties are reflected in the tree map hierarchy, and to increase the understanding of how tree maps represent data. And then they developed a tree map literacy test, right, to evaluate how well users can understand the data represented by tree maps. And then they conducted a classroom-based evaluation. So they took a class, a university class, split it into two halves. One half of the classroom was taught the tree maps using the traditional slides, and the other half was taught using a combination of slides and this software, this interactive software tool. And then they conducted some evaluation to see how the two halves of the classroom perform on the second half of the visualization literacy test, Well, it's a tree map visualization literacy test, so it's focused only on tree maps. And here's a crowdsourced-based evaluation from Lee et al. I have to be careful what I say here. So Lee et al. Looked through a lot of literature, right? The K-12 curriculum, the educational curricula, and all the textbooks. They looked at the lots of visualization tools, news articles, and other sources in search of the 12 most popular visual designs used, just period, by the general populace. What are the 12 most popular visual designs? And they came up with these 12. These are the 12 most popular here. And then they used Mechanical Turk to conduct visualization literacy tests focused on these 12 most popular visual designs. Okay, so in terms of future research, if we summarize the future research in visualization literacy, pretty much every visualization literacy paper has further evaluation in their future work, right? Because it is difficult to get a conclusive evaluation in these experimental settings. New visual designs, we can see that there are lots of visual designs that have not been the focus of any visualization literacy literature. It's still a relatively young field, so it's certainly as a whole not very mature. Improving the software and improving software usability is a popular future direction. Improving the literacy tests themselves is a very popular future work direction. Conducting the experiments on larger and new, more diverse target groups, right? The target groups are typically like computer science undergraduates or computer science postgraduates. Studying the cognitive impact that a given visual design might have on a user, on a target user, and of course, the inclusion of new and larger data sets. And this is just a little summary of the contributions. So a lot of the visualization literacy papers contribute a novel visualization literacy test or a novel visualization literacy software tool or some other aspect of novelty. Okay, I'd like to thank everybody for their attention, and I'm happy to answer any questions or comments.
Thank you very much for the interesting talk or half tutorial, literature overview in the area of visualization literacy, which is interesting to all of us. Are there any questions from the audience?
Hi, Tobias Merz from IEEE. Thank you for the talk, first of all. It's really interesting. So my question, if you encounter visualization in the wild, there's often some common mistakes in the design or even purposeful misrepresentation of the data. And you have to be visualization literate to recognize these misrepresentations. Do any of the existing evaluations consider this explicitly, or do you think that's even necessary to consider explicitly the ability to recognize these?
I'll try to answer that. So, like one of the common themes in the literature is the before and after tests. So usually the tests conduct some visualization literacy assessment initially that says, okay, what is your current level of visualization literacy? And it would be in that stage that we might have this assess, okay, here's somebody that might not understand something. And then they go through a process. And the process is usually to increase their literacy, that's the goal. And then they take a test again, another assessment of their visualization literacy. So yeah, it sounds like what you're talking about is that initial assessment of, okay, what do they already understand versus what do they not yet understand? Does that sort of answer the question, or?
Yeah, I think so, yeah.
But I mean, your question applies to everything, actually. Because imagine you study human-computer interaction, just general human-computer interaction. When you walk through the world, you notice lots of interfaces that are not well designed, right? The classic example is like a push interface for a door you're supposed to pull, or vice versa. So the same is going to be true about visualization, right? You're going to walk around the world and notice lots of problems, you know, as one does. Any other questions?
Yeah, I would like to add something on to the question you just asked. There is a paper that was accepted to the ACM Chi this year. It's called CalVi, where they looked at the ability to critically evaluate a visualization. So I think there is a test something.
What's the name of the paper?
CalVi.
CalVi, with a C or a K?
CalVi with a C.
With a C.
Yeah.
C-A-L-V-I.
So they give visualization that have problems in it, truncated axes, or things like that. So if the user can detect those things, and they are good in critically evaluating the test.
That's also I think that's the last stage of Bloom's taxonomy, is the critical analysis and evaluation. And we have done some work on that, actually, with respect to parallel coordinates plots. So showing people parallel coordinates plots with flaws and problems in them, and seeing if they can identify what the flaws and problems are. Another question?
One question. I can then.
If I can't answer this, maybe.
So, Lena Cebulski, also from Frankfurt IHD. Thank you for the talk. When you reviewed the literature, did you notice a difference between, let's say, novice users or casual users and domain experts, like either in designing literacy tests or in designing approaches to increase literacy? Like, what role does the expertise of the user play?
That's a good question. So our personal experience is kind of not too surprising. It's always university students, and it's always computer science students too. And one of the problems we actually ran into in one of our experiments is that the literacy was too high. So when we assessed the literacy before the test, we had one group that scored extremely high, like almost perfect scores on the pre-literacy test. So that didn't create very good results, because there's not much improvement you can make. In fact, maybe even the scores went down after the intervention, so to speak. So I think that plays a very big role. Like, the demographic that you're testing is going to play a really, really big role. Yeah.
Do you have an idea on how to kind of address that, like how to integrate that in the way you evaluate literacy? Did you have a question?
I think it's like, for example, one useful thing to do would be to recruit non-computer scientists into your experiments. So look outside of your computer science classroom. Yeah.
Thanks.
That would be good.
So one question. So the literature group was pure visualization literacy literature, I assume. So where they looked at bar charts, for example, but did you also cross-reference with how they are used in applications later on, and if there are user studies in applications related to premaps, for example? So you showed the bar charts with how many visualization literacy literature.
Yes. Yes. Say that 10 times fast.
Yeah. So
that's not the one.
I think yes, this one. Yeah. There's not much literature about spiral charts, for example.
Yes.
But
Yes.
Is there a reference how often it's used in applications and tested there, and not purely in the visualization literature?
So the scope of this work is we had to be very careful when defining the scope, because there were some scopes that opened up the number of papers to be too big. So this has a pretty narrow scope. Like you said, it's focused on, let's say, basic research, not the applications actually. And this is one of the future research directions, how does this translate into real applications and real data sets, not such academic data sets, because a lot of the data sets are very academic that are used to test the literacy. So yeah, that's a good future work direction. And while I'm at it, there's another set of literature that we left out, and that is static graphs and networks. So there's a body of literature from cognitive psychology and the visual cognitive psychology that looks at static graphs and static networks, and it does so from a visualization literacy perspective, and we have not included that here. We're talking about interactive visualization, actually. So there's a whole other body of literature that we couldn't include because it would be so big. It would be a big scope.
Thank you very much. As we are running out of time, final question by like opening and closing. By the
exactly. So this is the bridge to the closing of the first session. Kind of related to the last question. On this journey that ended with this paper, or started with the paper since you have future work in front of you, have you thought about alternative ways to kind of categorize things? Was there a debate amongst you whether this is the only way to kind of, set of criteria, how is things being evaluated, and that's it? Or did you think about other ways to classify other sets of criteria?
We made an attempt. There's the start of a survey paper before this called Visualization in Education Towards a Survey. That's what it's called. Or it might be called Towards a Survey in Visualization in Education. So we made an attempt prior to this, and the organization was centered around a topic. So it was what is the topic we are trying to understand when we're looking at a visual representation of data. For example, is it biology? Like, are we trying to understand our knowledge of biology, or mathematics, or chemistry, or physics? So that's another sort of categorization that we discussed, actually. We struggled with that because the scope ended up being too broad, actually. So, yeah. But certainly there are other categorizations that are possible.
So, thank you very much. I would like to thank Andre for organizing everything. I would like to thank the speakers for coming and presenting their work. And I would like to thank you very much for your attention, for coming to the session, and wish you a very pleasant stay at Eurovis for now. Thank you.
With greetings from IEEE. Thank you for hosting the session.
Wow, thank you.
That's good.
Thanks for coming and for your talk.
Wow, thank you.
I really appreciated it.
Thank you.
And I've learned a bit about CG&A before my time of EIC. And actually, we had the same fate as you with the invitation to this. With our 2021 paper, we were too late. And so
that's funny.
May I ask you, they are free to also come to the...
Thank you very much. Yes. Very much.
Thank you for your talk. So, thanks, enjoy the break, and we have another session right afterwards. So, hope to see you back soon.